Let f be a function defined on a curve of finite length. Then the line integral of f along a given curve C is defined as integral over C. F is the function. Then we'll have ds. That will be equals limit n goes to infinity, summation I goes from 1 to n. So the function x, y values we'll write as a discretized form like xi, yi, and then delta si. In two-dimension case, if you have a two-dimension case, it's like that. When you have a three-dimension case and n approaches infinity, summation I goes from 1 to infinity, sorry, 1 to n in this case, because I'm taking limit as infinity n. So f of xi, yi, gi, and we'll have delta si. Now, what is delta si? This is coming from the curve. So then we say ds will be equals, it's another form of dsi, will be x prime squared plus y prime squared plus g prime squared dt, where x is a function of t, y is a function of t, and g is a function of t. Okay, so this is roughly the idea. So we'll take an example. All right, we have an example that we are taking the line integral along the curve C of the function x to the 3z ds, where C is the line segment from 085 to 734. So as you know, in vector form, we can write the equation of the line segment RT. That will be R naught initial position plus T times the direction vector, where our direction vector V equals terminal minus the initial, then 3 minus 8 same way, and 4 minus 5. So a simplified form gives you 7, negative 5, negative 1. That's the vector. So then RT comes out like 0, 8, 5. That's the position vector initially, plus T times the direction vector 7, negative 5, negative 1. And you can combine this one as 0 plus 7t. So you can write 7t, 8 minus 5t, and 5 minus t, right? And parametric form of this one, you can say x is 7t, y is 8 minus 5t, and g equals 5 minus t. So then x prime now gives me 7, y prime gives me negative 5, and z prime gives me negative 1. So then my ds now, that is square root of x prime squared, y prime squared, z prime squared dt. And remember one more concept, that when you write your vector in this format, the t limit will be always between 0 to 1. The reason is when you plug t equals 0 in this equation, you can see that you are getting 0, 8, 5, which is the initial point. When you replace t by 1, then you get 7, 3, 4, and that's the terminal point. That's why the t limit is this. Okay, now plug all the values in here, simplify. You will get this one square root of 75 dt. Okay, so we are now going to find the integral of this one. The limit goes from 0 to 1. X is 7t, so you can exponent here, and g is 5 minus t, and ds is giving me square root of 75 dt. All right, let me take all the constants outside. So I will have 7 to the 3 square root of 75. Then I have limit 0 to 1, t to the 3 I will distribute inside, so I get 5t to the 3 minus t to the 4 and then integral. So you get 7 to the 3 square root of 75. Then the integral of this one is giving me 5 over 4 t to the 4 minus t to the 5 over 5, and our limit is 0 to 1. Now plug all these limits here. You get this, keep this constant in front. Now when you plug t equals 1, you get 5 over 4, and there you get 1 over 5. Now simplify this. 7 to the 3, 75. You can just do multiplication with the denominators, which is 20, and then cross multiply gives you 25 minus 4. You don't struggle with simplifying fractions. So then 25 minus 4 is 21 and over 20. So then I'm getting 7 to the 3 square root of 75 times 21 over 20. I just want to keep this way.